Hello, welcome back to the video lecture series for Introduction to the Art of Programming Using Scala. In the last video we looked at the most basic usage of the for loop, and in this video we're going to continue playing with our for loop and add one extra little feature to it. So in the last video we used the for loop as a statement. So I had examples like for I in 1 to 10, print line I. And this usage was much like the while loop in that it did stuff for us, it didn't give us back anything. And unlike the while loop, the for loop can be used that way, but it can also be used as an expression. Okay? So the while loop and the do while loop are really the only constructs that exist in Scala that we can't use as an expression. I can make my for loop return values for me. So to see this, well, we can run through an example, and the way that we do this is we use the keyword yield. So let's go for val evens equals for I in, and actually let's go with even squares. Even squares is for I in 2 to 20 by 2. And then after the for loop, after the in parentheses where I have the thing that generates the values here, the generator, I put the keyword yield, and then I put the body. And so if this were long, I'd put curly braces and whatnot. In this case, all I want is I times I. And you can see when I do this, I get back a new collection, which has, this is 2 squared, this is 4 squared, this is 6 squared, 8 squared, 10, 12, 14, 16, 18, and 20. Okay, so we have the squares of all of those values. It gave us back something that is a new type to us called the vector. And now to help understand this, let's go back and let's use let's make another array called nums array dot fill. I'm going to make it so it has 10 random doubles in it. Now what happens if I do a for loop where I run through all of the nums and then I yield, well, in this case let's go, same idea, let's yield the squares of those. What do I get back now? So if I use an array and I do inside of my for loop and I yield, I get back an array. Turns out if you use a list and you yield, you'll get back a list. This was neither an array nor a list. This is the type we saw last time. This is a range type. And the problem is that the range can only be things that are evenly spaced. And when I do this, I'm not guaranteed they're evenly spaced. So it gives me a slightly different type called a vector. The vector isn't anything complex. It's kind of what happens if you combine an array and a list. It's immutable like a list, but it has the ability to quickly index it into it like an array. So for the most part, at this point, you can just think of a vector as being, it's a sequence. It's just like the array and the list, and that except that it's immutable. And that is what your ranges will wind up giving you back if you use them on a loop. So let's say I want to have something that tells me whether or not a value is, let's see, what would be a good way of doing this? For every number that's inside of, or how about I do this? What if I want to yield booleans that just tell me whether or not the particular x values are less than something? So this gives me back that, and then that's stored in res2. I can use some of my higher order methods and count how many of those are true. It's kind of a roundabout way of counting how many things were B rocket B. Okay. How many things were less than 0.5? Well, that's unusual. For 10 numbers, I only generated 2 that were less than 0.5. So you can put a yield on any for loop that you want and make it produce a value for you. As you saw, the type of collection that it will wind up producing is based upon what was passed in. Let's say I had a whole bunch of points. So let's go ahead and let's manufacture a bunch of points. I'm going to do an array.fill, and I'll make, I don't know, 100 points. And I'm going to represent my points as tuples. And once again, to keep things simple, I will make them all random values. So now I have 100 points that are randomly distributed inside of the unit square in the first quadrant. So x values and y values both go between 0 and 1, inclusive on the 0, exclusive on the 1. And now I want to produce a new array that has the distances of all of these things from the origin. Now we could have done this with map, but we can also do it with a for loop. And really, which one you decide to do is kind of a matter of style. Now there is one advantage to this, and we'll come back to this in a bit, which is the fact that, so I could say that this is for tuple t in points, and then I could use t_1 and t_2 type of things. But what you put here in a for loop can actually be a pattern. And so I can go ahead and pull out the tuple xy, and then I can yield the value x, let's do math.square root of x times x plus y times y, and close off that. And so now I have all of the points, their distance from the origin. And it might be interesting to do something like, how many of these distances are something less than 1? And it turns out that that actually should be, this is close to an approximation of pi. The so this is embedded in a square that has, so it's because it's 1 by 1 on each side, it has an area of 1, and that quarter of the circle, so if we were to draw a unit circle that's centered at the origin, a quarter of it, all the points that have a distance less than 1, that would have an area equal to pi r squared over 4, because it's the whole circle divided by 4. So since r is 1, it's just pi over 4, capital P. And if for 100 points we would have expected this to be 78, 79. Of course, there are error bars here because these were drawn randomly, and we got, in this case, a value of 0.69, which then if we multiply by 4 would be an approximation for pi, generating random numbers. This is actually closely related to an exercise that was shown in the chapter on recursion. That same exercise could be repeated here, but using for loops instead. So this is a brief introduction to how we can use yield in the for loops to make it so that they give us back values, and we're going to have more videos where we continue to see some of the other aspects that are possible with our for loops, so that we could possibly do these things in more do more interesting things with them. And really what it comes down to is the for loops are remarkably powerful, and they have a lot of options, even though most of the time you're going to do just what we've done so far. A basic for loop either as a statement or a basic for loop as an expression. But we'll see the other possibilities in